Welcome to this explainer. Okay, today we're taking a really fascinating look under the hood of the automotive manufacturing sector. When you look at a job description, it's super easy to just see a dry list of responsibilities. But today, we're going to reframe a very specific, highly sought after role, the automotive cost engineer. I want you to completely forget the image of a quiet accountant crunching numbers in a back room somewhere. Instead, think of this role as the ultimate financial detective of the automotive world. They're the investigators who track down hidden costs, interrogate data, and solve the real mystery of what a car should actually cost to build.
Okay, let's dive into this. It sounds like a remarkably simple question, doesn't it? How much should a car part actually cost? But for automotive manufacturers, this is the core mystery they face every single day. Think about it. An average car has around 30,000 parts. If a company overpays for even a tiny fraction of those parts, millions of dollars in profit simply vanish. Poof, gone. That's exactly why the answer to this question can't just be a gut feeling or guess. It literally has to be a scientifically calculated certainty.
And that brings us to, well, our hero of the day, the assistant manager of costing, typically armed with about 3 to 7 years of hardcore industry experience. They are the financial detectives tasked with solving that true price tag mystery. Their job isn't just to casually glance at a supplier's quote and say, sure, looks good to me. No, their job is to interrogate that quote. Is it actually reasonable? Where's the padding? Where can we champion cost reduction without sacrificing even a single ounce of quality? They are quite literally the frontline defense against bloated budgets. And this brilliantly illustrates exactly what we're talking about. 1,550 rupees. This isn't just some random number pulled out of thin air. According to our source material, this is the exact calculated manufacturing cost of a sample exhaust pipe. To a cost engineer, they don't just see a curved metal tube. They see a very specific compilation of financial data that leads exactly to this precise number. So how do we get there? Let's fast pace through exactly how this 1,550 rupees is sliced up. Material takes the biggest chunk at 800 rupees. Then you've got fabrication coming in at 300, welding costs 200, overheads sit at 150, and finally coating is a neat 100 rupees. A cost engineer is constantly looking at this kind of breakdown, hunting for savings. Could we maybe get the material for 750? Can we optimize the welding process to shave off just 50 rupees? Literally every single slice is an opportunity. Moving into Section 2, the Investigator's Toolkit, Understanding Manufacturing. To actually dissect these costs accurately, our detective needs some serious technical chops. For instance, a mandatory requirement is mastering sheet metal processes. We're talking about blanking, piercing, bending, deep drawing, stamping, and roll forming. You simply can't catch an inflated supplier quote for a bracket if you don't actually understand the machinery, the expected scrap rate, and the physical limitations of the metal required to make the thing in the first place. It's also worth noting the specific domain expertise required here. The source highlights a really deep focus on exhaust systems. Manifolds, flex pipes, catalytic converters, resonators, mufflers, and tailpipes. This is a massive clue for any candidate looking at this role. You aren't just estimating generic pieces of metal. You have to understand the exact assemblies and subcomponents of an exhaust system to build an accurate cost model. Which brings us to the whole fabrication costing cycle. First up, you evaluate the type of welding needed. Is it MIG, TIG, or spot? Second, you assess advanced processes, things like robotic welding and tube bending. And finally, you determine the exact cycle times and assembly costs. Imagine the pressure of doing this. You calculate that a robotic weld should take precisely 14 seconds, and then you have to sit across from a seasoned veteran supplier and defend that assumption when they try to insist it takes 20. It takes a lot of confidence and impeccable math to win that argument. All right, Section 3, the cost engineer's superpower, VAVE. This brings us to what is, honestly, probably the most highly demanded skill in automotive companies right now, VAVE. It stands for Value Analysis, Value Engineering. At its core, it's the process of continuously identifying cost-saving opportunities and improving manufacturability. And listen, it's not just corporate jargon, it is the ultimate competitive advantage. It's the primary weapon a company uses in its product cost reduction programs to actually stay profitable in a brutally competitive market. So the crucial point here is understanding the dual mandate of VAVE. It's a really delicate balancing act. On one side, you absolutely must reduce the product cost, maybe by proposing alternative manufacturing processes or using slightly thinner materials. But on the other side, you absolutely must maintain the part's functionality and quality. You do this through clever design simplification or part integration. You're slashing prices, sure, but you cannot sacrifice the integrity of the car. It's basically brilliant engineering disguised as cost cutting.
Let's move to Section 4, day-to-day detective work, the ecosystem.
So, what does the daily grind actually look like for our financial detective? Well, their daily responsibilities make them kind of the central hub of the manufacturing lifecycle. From the exact moment a request for quotation, or RFQ, hits their desk, they handle costing by analyzing engineering drawings and cycle times. They conduct supplier cost analysis to validate those quotes. They lead VAVE workshops to drive down product costs. And perhaps most importantly, they manage cross-functional coordination. They're constantly battling and collaborating with design engineers, the purchasing team, and external suppliers just to keep everything on track and on budget.
To survive in that ecosystem, they need a pretty vast arsenal of knowledge. They have to master industry quality frameworks and methodologies, things like APQP, PPA, PAP, lean manufacturing, and Kaizen. And on the tech side, well, advanced Excel's a total given, but they also need to navigate SAP, ERP systems, AutoCAD, CATIA, and Power BI. Mastering these tools isn't really optional. It's honestly the only way to manage the massive, overwhelming scale of data in the modern automotive industry. Because, wow, we're talking about massive scale here. A cost engineer might be interacting with, benchmarking against, or supplying to absolute giants of the industry: Tata Motors, Mahindra, Renault, Hyundai, Maruti Suzuki, Volkswagen. The sheer volume of parts these OEMs require means that even a single 1 rupee saving on one tiny component translates to millions in overall savings for the company. That is the arena these detectives play in.
Let's move to and see how this builds in Section 5, the payoff, salary expectations, and interview prep. If you actually have the skills to save an OEM millions of dollars, what's the payoff for you? Based on the source data for Pune looking ahead to 2026, here is the expected bounty for these skills. For 3 to 4 years of experience, the approximate cost to company, or CTC, is between 6 to 9 lakhs per annum. 5 to 6 years pushes that up to 9 to 14 lakhs, and 7+ years of experience, that can command 12 to 18+ lakhs per annum. Now, it's important to note that actual salaries are definitely going to vary based on the size of the company, whether they're a Tier 1 supplier, and of course, your specific domain experience.
If you want to claim that salary, well, consider this your personal interview cheat sheet. Hiring managers are going to expect you to prove your financial detective skills right there on the spot. You need to be ready to calculate the cost of a sheet metal bracket or a full bill of materials right there in the room. You have to know your material yield and your welding calculations inside out. They'll ask you about RFQ methodology, they'll absolutely expect you to present VAVE case studies from your past, and they will grill you on cycle time estimation. Which leaves us with one final provocative thought to wrap up this explainer. I want you to imagine you're sitting in the cost engineer's chair. You've done all the math, you've optimized the design beautifully, but overnight, global raw material prices suddenly spike. How would you handle that fierce supplier negotiation to protect your company's bottom line? It's a high-stakes game of numbers and strategy, and honestly, it's what makes automotive cost engineering such an incredible puzzle to solve. Thanks for learning with me today.